Okay, we're going to start with ICF valve stations. Okay, I can't imagine that any of you in here maybe haven't worked on one, but that you haven't seen one. ICF valve station or one like it. Sometimes they call it modular block valves. We call it ICF valve station because it's that Danish. It's something in Danish that those letters stand for something. Somebody tried to make up something that makes sense, but to me, I mean, integrated is a good word because it integrates multi-functions all into one. But it's ICF valve stations is the best I can tell you. So how does it work and why do we do it? Well, simply put, the normal would be all of those components with either flanges or threaded or individual well connections, typically with ammonia and CO2, all the way across there. So how many leak points do you have there? And then down below is our ICF valve station. Okay, you've got the modules that are bolted in, and then you've got two weld connections to put the valve body in. So although you have other leak points, you eliminate with the two welds, you just simplify it and you hopefully eliminate the two basic ones that you want to eliminate. Then yes, you could have a leak from a module, that is possible, but it's easily replaced, a gasket. It's really, actually it's rare in my opinion, if everything's done right, put together correctly. So, what is you get the concept. So here is our family right here. The smallest, the 15, then the 20, the 25, and that is the metric, so you're talking 3/4, half inch, 3/4, 1 inch, the 50 is essentially 2 inch, and the 65 is essentially 2.5 inch. Okay, our two largest ones now have been introduced recently, is the 50 and the 65. Now, again, keep in mind that is the module port size. So the connection sizes can be different for each one. Can be anything from a 1/2 inch through 3 inch connections. Okay, so it depends on the particular one and what you're trying to do, within reason. I mean, obviously you're not going to have a 1/2 inch connection on an ICF50. It's not happening. Okay, so you get the gist of that. Here is just the flow and the side port locations. I have one up front here that around lunch, and it would be best because it's so big around lunch. I would encourage you to look at it if you want to, but I'm not going to pick it up. I'm not going to bring it to you. It's just too heavy, but you can see it from here. And you can see what I have over there is an ICF 25-6, okay, which would be this particular one right here. It's the most common in large jobs that I see, and you can see the flow from inlet to outlet. You have the odd modules are on top, so M1, M3, and 5. The even modules are on the bottom, M2, M4, M6. If that was just a 4, then it would be M1, M3, and M2, M4. It's that simple. The side ports there are called the P ports, and it shows you kind of where they are. So in most cases, the P ports, the side ports, are going to be in between modules. Occasionally, one of them will be at the module. Okay. And then the large 50 is 4 modules, up to 4 modules, and the 65 is the one that limits to 3. So, just as an example, this is typically what happens is here on this one, which you can't have on here, you can add a filter strainer to the M2 location. Here you would have to have a separate large strainer for the 65. Okay, so starting with the small ones, the 15, it's kind of a morphed body. You can see it kind of looks a little weird there. The size of it required that, and the fact that we're trying to use some of the same modules from the SVL line, just in this particular case. But the point is, on the 15, you can have a stop valve, and you can have all of these others. The nomenclature is pretty simple. So a stop is an ICFS, S for stop. Then you've got ICM Motorized Module, we'll talk about that one later. that's a separate item in our line. We've got an ICFA, which is a solenoid. That's a pulse. Then ICFE is a solenoid. The O is the manual opener. S and N are stop and stop check. And then ICFR is a regulator. So that's what can go into this, this particular one, the 15. And you can see up here how they do have to go in specific locations in many cases. Then the 20 just increases. It's got a few more that we didn't talk about. I'll try to point those out. Let's see, here we go. High capacity solenoid. We do have the filter in the other one. Check valve, okay, so that's another one. Check. ICFC, and everything else is, and there's another one, a blank. Okay, so let's say that you got you need 5 functions. You just have to have 5 functions. Then you're gonna have to use an ICF something 6-6 because we don't have a 5. Okay, so you're gonna have 6, so you're gonna have an opening, so just put a blank. Just put a blank cover in where you don't need the functionality. And the 25- we used to have what was called a 25-40, the 1 inch. Okay, so remember I said the connections can be pretty much what are needed within reason. So we did away with the range between 25 and 40. I need all our slides have things that we need to update. But suffice it to say today we only have ICF 25. There is no such thing as a through 40. It's basically the same because we give the variable connection sizes, and the port size is always going to be the ICF 25. Here, it adds another one. So you see this one. This one's pretty interesting, but only for the 1 inch. It's called a welding module. It's pretty cool. So if you think about it, I don't have one, but you see that if I were to put, let's just say I were to put on the outlet, which is this end, I could put, because this is socket weld, I could put an outlet here. I could also put an outlet up here, and I could pipe away from that thing and do something. I mean, yeah, I've got an example of one. It's pretty crazy, and people do all kinds of stuff with them. So it's just a way of bringing the refrigerant out at a certain place on the ICF valve station. Yeah, I don't see anything else there. Oh, the one that I told you about, the unique 25 solenoid. It's the one with the armature to the side. And the reason for that is just the size of that valve and the fact that the manual opener comes built into it. The other solenoids, you have the valve in the solenoid at the top, so the manual opener goes down below it. Okay, and you can't put that anywhere else. I've actually gotten that question before from the field. Can I put the manual opener anywhere in the valve station? I'm like, no, you got to put it underneath the solenoid, otherwise it won't work it. So just something to know. Here's a breakdown of where the modules must go. We'll do the simple ones first, okay? So the stop valve and the manual reg, they all need to go in any, they all can go in any particular position, M1, M2, M3, M4, M5, and 6, okay? The filter module has to go in even or at the bottom. And that kind of makes sense because you want the filtrate going down, not up, okay? The solenoid valve module goes in M3 only, and the reason for that is a machining thing in the valve body itself. It was one of the things that they could not make a compromise on when they designed this. So you'll always see that solenoid valve module in M3. It doesn't matter what size you have, it's going to be in M3. Then check valve, okay, this makes sense. Check valve goes down below. It's that gravity thing we talked about. It's going to go down in the evens. Stop check, the same thing, M4, M6. Motorized valve, always in the top, so the odd numbered. Of course, blank module can go anywhere. Electronic, it's like the solenoid. And manual opening is M3 with the solenoid, okay? And then the last one is the welding module. Technically that can go anywhere. Typically it won't. It's going to go where it needs to go for whatever the design is. But I have an example later for that. Okay, you might ask, these modules for the stop valve are, they're unique to the ICF valve station. The ICF15 is the only exception to that, but the reason for that is because you can mount this upside down, and we typically don't want valves mounted upside down. So in this case, this is a special valve, and it has a specially designed cone, so it's not like our standard stop valve. So just you need to be aware of that, I guess, just so that you know it. It does use the same packing gland as the SVL line, but the valve itself is not the same, so it can't be substituted. So what I'm saying here is this is an ICF stop valve, and it has to go in the ICF valve station. It can't go anywhere else. So regulator, okay, it's again, same packing gland. We talked about V-port regulation. That's how the regulators work throughout our family of valves, pretty much. Can be mounted in any location. Regulators are typically, is the way it works with ICF. Regulators tend to be at the end, generally, makes sense. And stop valves will be at the beginning, and if you're not doing stop check or a regulator, it'll be at the last position, just to make isolation of the module, of the valve. Let's see here. Seal caps, we don't need to cover this because really I've already talked about it. They just need to be, we like people to use them, put them on. I see them on the roofs, usually they're upside down, they're all over the place. It's just best to have them on, tight, nice and tight. And kind of keep up with them. There's a torque related to those caps, and that's in our literature. Okay, we talked about reversing it to use it to drive the valve, and the color coding of it. The filter modules, we have two. We have a standard and we have an extended. Today, pretty sure we've gone standard with the extended module in the ICF valve station. It's something that we've done, and like I told you earlier about the pleated, we standardize on pleated in certain applications. We recommend it and standardize on it. Okay, so there's a drain plug. It's a 3/8 inch MPT. So typically what we see is that they would get a 3/8 gauge, or valve, gauge valve, or purge valve, and they would use that and install it into that, so that when you isolate the valve station, you want to clean the strainer, you're going to purge after you isolate, and then you're going to take the strainer out. Can only be mounted in the down position. We already talked about that. And you can tell the extended, I forgot to mention this, but you can tell the extended filter, the bolts will be long. On the standard, the bolts are going to be really short. You can see that in the picture right here. Okay. And I'm not going to go into the micro details of sizes and parts and all that stuff. It's more, just knowing that it's stamped on the side, like I showed you, what they look like, that we have standard and pleated. Those are the things that I think are important for you guys to know. Check valve is very similar to the CHV and the SCA. You can see that, the piston, the damping orifice hole, the spring, all of that. I mean, it's pretty much the same. Low opening differential pressure, just like the CHV we were talking about, almost a half a PSI differential. Again, mounted in M2, M4, or M6. Otherwise, the flow is going to have a tendency to open that check valve, and that's not what you want. The stop check module. This was a mistake in this, so I just put a note in there. It comes with a green seal cap. But believe it or not, historically, I've looked into it and found out it didn't used to come a long time ago, when it first came out, they did red, and then they came up with this brilliant idea to color code them, so. I need to update this, but I just put a note there saying that, those are green for stop check, yellows hand regulating, red stop valve. The module, solenoid module, it uses a peak seat, okay, valve seat. It comes with so if you ordered that module, that solenoid, it would come with that. It can only be mounted in that M3 like we talked about because of the special machining in the valve body. What else? And then the manual opener, of course, that corresponds to that would go underneath it. There's the one exception is the ICFE 25 that has this built-in manual operator. And you see the automatic and the manual mode there. It's the standard. This is kind of unique. If you ever run into one of these, I get people who either like these things or if they don't, they hate it, and I don't really know why. It's a high capacity solenoid, so it can be used with the ICF 20. It's unique in that it's the other one that has a built-in opener, but it's not like the one we're talking about on the 25. It's kind of unique, and it's you can see the side picture here. It's a red colored cap that has a gasket underneath it, and when you screw that out, it uncovers this with an Allen head there, and the two things I hear is, well, so now I gotta have a hex wrench with me if I'm gonna operate that thing, and you know, I don't wanna have to mess with that, so couldn't you have like put something there that you just that you're gonna have, you know, or you can just take your hand and move it. Well, the reasoning behind that is you don't want it to actually be operated that easily. You want somebody to be doing it for a reason, and it's a tool thing. I mean, it's just the thinking of an engineer when he's designing this, I guess. The other thing is that you can easily break that thing. It only turns to the 3 o'clock position. So it's at the 9 o'clock position when it's in automatic, okay? And then to do manual, it's clockwise to the 3 o'clock position only. So what'll happen is if you get in a hurry, you put your hex head in and then you just twist it. Well, if you're a strong fella, you're gonna break it. Unfortunately, it's happened, we see it. It's unfortunate, but yeah, it doesn't take much. You can, and I don't mean break the hex head, I mean break the internal manual opener part. So now you know what you're gonna have to do. You're gonna have to replace the whole module. So it's happened. Just be aware of that. And again, this is a solenoid module, so it has to be mounted in. That's one thing that's common throughout this. There's the special one that we talked about. It's backwards. Okay, just keep that in mind. Again, only M3. In a way, it is, because you can see that the solenoid is off to the side, it's kind of a pilot operated type arrangement. It's not direct acting, it's pilot operated. Pulse expansion module. Okay, so that's going to be an AKVA type. Thus the A there at the end of the ICFA. We have a line of AKVA and AKVA for ammonia. M1, M3, M5. So this is a little more flexible because it's not actually a solenoid valve, it's a pulse valve, electronic pulse valve. And this is one we haven't talked about, but we'll talk about it separately after lunch, shortly after lunch, is the ICM Motorized valve. So what's unique about our valve station is that there's so many different things you can do, including we're looking in the future to being able to, on the small ones, to be doing ICS. And I haven't talked about this, but there's limitation of what you can do with the 15, 20, and 25 valve stations with ICS, okay? So ICS pressure regulators. But you can do those across the board with the large. The 50 and the 65 are very flexible. They're working on the small. There's just some challenges really, I think one day they're gonna come with it. So it's gonna be pretty neat because a lot of people like the fact that we can also do the motorized valves on the valve stations, and it is pretty cool. Because let's say you're wanting to do liquid injection on a compressor, let's say. That's common with compressor manufacturers. They really like using that valve station. It has everything they need in a motorized valve to feed the liquid. It really is nice. And typically those don't get very big, generally speaking, so it's working today, but there's a lot of applications where having regulators for the small would be good, because we already have it for the large ones. Okay, well, and blank cover, that's straightforward. Okay, this is one that you may not see, and you may not ever see it. I don't know, but I do it real quick because I want you to be aware of it. It's brand new. It's only been out a year or so. It is a defrost float module. Can only be used in the ICF valve station. And it can only be used in the 15 and the 20. And it's not in the 25 today. Okay, it's designed on a mechanical float. You'll see that in a minute. It's got a built-in bleed to bypass gas. It has a very high capacity, so we're talking in terms of system capacity, not defrost capacity really, but system capacity, about 55 to 60 tons, okay, system. So that's pretty good. It's got a manual opening stem that's actually similar. It's on the back side here, and you'll see it's similar to the ICFH high capacity solenoid. It's a little cap with a red cover. It's actually very similar. And in the picture here, you can see that you can have an ICF-4. You got a stop valve, you got a float drainer, you got a solenoid, and you got a stop valve. So what you're going to do is the stop valves are always going to be open, and you're going to engage the solenoid during defrost. It's that simple. So when you're out of defrost, you de-energize the solenoid. You'll see in a diagram here in just a second. So the feed from the condensate out of the evaporator is going to feed down into the center, go into the float chamber, and the float is only going to allow liquid here on the outside of this to come out. Any gas up here is going to be controlled by an orifice, so the bleed of the gas going back to the system, the liquid separator, and then ultimately back to the compressor is limited to like very small amount percentage-wise. The idea there is that, any gas in defrost, if you're sending gas back to the system to recompress it, that's the energy loss. I mean, there's no savings at all in that, because compressor's going to recompress gas that's already been through the process, and it didn't do any good work in the evaporator to defrost. Okay, so the idea is you want that to be maximized. That's what the float drainer does, is it forces only liquid to pass. And the only reason the gas port is there with the orifice, which by the way can be sized, can be changed, is to allow the siphon to take place. Otherwise, maybe it wouldn't work quite as smoothly. So allowing the gas to bleed is what actually allows this thing to work. The key to this, one other thing is that you can have a purge down here at the bottom. So when this thing is shipped, there's a plastic plug in here, okay, that's screwed in, and there's a tag on it, it's fastened onto it. So when you receive this, the reason for that is it puts the float in the up position to keep it from being damaged in shipping. So if you don't take that out, guess what? Your ICFD is not going to work. So you take that out, you put a fitting in there and put a purge valve, or you just put a cap. But most people put a purge valve. That way they got control of that. Here's just a simple diagram, but take note, it's advisable to put a trap here in the condensate riser. And also there is a limitation of the ICFD, and it's not a problem in Europe from what I'm understanding, but I go to a few job sites where the vertical lift, because of the configuration of the job site, that vertical lift is more than 16 feet, and if it's more than 16 feet, it will still work, but it will work in a limited fashion. So it kind of doesn't make sense to put it in, because it's going to work in a limited fashion, you might as well just use a drain regulator, honestly. And so that's being looked at and worked on, but it is 16.5 foot vertical lift is maximum. You want to be inside that, be less than that. This example here is a shared liquid riser, so you can see that the condensate's coming up into the float, and then it goes into the side port of the ICF, a large valve station, and is returned back to the wet suction. That's that one example, okay? Then the other example would be where you have 4 pipes, okay? So you have hot gas, you have liquid, you have suction, and then you have a separate drain condensate line going through that, and then that's going to either go back to the system. So it's typically going to go into the side of the ICF valve station. It depends on what they want to do, but that's where we would like to see it go. Because during defrost, see, that's going to be closed. The side port, though, is going to be open to the wet suction, and just condensate's going to go, defrost condensate's going to go in there. So that's just kind of an example of what that would look like. So you've got a hot gas regulator here, you've got liquid, and then you got suction, and all in ICF valve stations. And I see this, I go to a lot of job sites, and it's gratifying to see this in real life out there being used actually a lot. And generally I get positive comments because it is just so much cleaner, easier to work on, and if it's put in a good fashion, it's easier for you guys to get to it and work on it. You know, it's not spread out all over the place. And you'll see that in some example pictures here in a minute. Here I want to just reiterate the large and the concept of it. It's really nice. So I've got an ICF 50-4. You could have a strainer, as we talked, you could have a strainer down here, and then you're going to typically have a stop and a stop. And in the middle, M3, you're going to have a variety of things. It could be the ICS pressure regulator. It could be the ICM motorized valve, which I haven't talked about yet. It could be the ICLX suction stop that I did talk about. And it could also be the ICSH, our new safe or soft start hot gas valve. So this I see today and a lot. I see it a lot, and it's pretty cool to see it being utilized, and a variety of things being used. The most common that I see in suction is ICM and ICLX, and of course ICSH, generally only in hot gas, but I like this gentleman's question here, and I'll look into it. You could use it in liquid if you needed a 2-step, so I need to make sure of that, but I'll try to feed that back through to the IRP guys once I find that out, because I don't really know. And then 65, the only difference here is the size and the constraint of the filter module. You can't have it; it's just so big. These guys, these things. This 65. I mean, if I had one here, I'd have a crane. I'd have to have a crane to pick it up. It's just so big. It's hard to manage. The 25 is big. I mean, you can imagine I'm carrying that around in a Pelican case. Yeah, that's no small piece right there. Okay, so I didn't say this before, but you can use regulators in that last. It's not common, but you can use a regulator in that last. But generally what I see is a stop, and then some function in the middle. Accessories, so we touched on this a little bit because it's a similar connector. But here's your defrost drain connection for the 65 and the 50, and it goes in that large. There's a small side port, there's the large. That's NPT, that's G. So you're going to have a gasket, you're going to have an adapter. But it's really nice to use that for condensate return, and it's used a lot. We did have an issue with that cap, that plug, whatever you want to call it, on the large, and I discovered that just by accident. It's not always used, so I guess a guy down in Florida had a big job, and he used it over and over and over again. He had to take that valve station, unfortunately, to a industrial shop that had impact wrenches that would operate up to 300 to 350 foot-pounds. It was the only way they could get that thing out. So what happened was I went back to the factory, and it was just a matter of them not in production. They weren't lubricating that when they installed it. So if the torque is, say, 150 foot-pounds, which is about what it is, to install it, you would expect it to be, breakaway torque to be less than 150 pounds, and it should have been. Well, it was twice, almost 3 times as much because of what we discovered. And the minute they did a slight oil or lubrication on it, probably went away. So if you run into that out in the field, it's been fixed, but if you were to run into that, just know it will come out. You just gotta use some, you won't get it out with your elbow grease, because I can tell you your breaker bar would have to be, but yeah, you can get it out with an industrial, it's a 41 millimeter socket is what it is. I know that because I had to do some testing on it. So that's a little sideline to let you know that. Filter strainer insert, that's the one I have over there. We now standardize on the pleated for ICF valve stations and then other applications. You'll still see the standard strainer in the SVL line. And so here's an evaporator valve group. Okay, see all the valves. So you've got hot gas, you've got liquid, you've got the condensate drain going back to the wet suction, and you've got the suction line. So you got individual valves all over the place, and so you got these ICM. It's not used for hot gas a lot. I think now we're doing more of that step valve. And I see the ICM on suction now actually a lot. And then here's what the valve station does for that. Kind of cleans it up a little bit and makes it look really nice. And of course, this is without the float. It's using a drain relief regulator. We talked about the standard STD version for that. So here's your valve stations. And this is the ICFD, the defrost drain. It just shows you, okay, so if you use a pressure regulator, pressure control, what's going to happen is your defrost is going to continue, and it's going to return a lot of gas at the end back to the system. Here, the liquid drain is limiting that and only allowing liquid. Okay, so at the end of defrost, it's saving energy is basically what it's doing. That's a picture of what the float drainer does for you. It equates into energy savings, absolutely. The compressor's not going to work as hard. So, just some applications that are popular. Liquid injection on compressors. It's with ICF, like I said earlier, with ICM motor, it just cleans it up really nice. It's super nice. The compressor guys we work with, you'll see that actually used quite a bit on some of them. Then a makeup to a recirculator, liquid separator. You're basically feeding in from the receiver to the liquid separator with an ICM valve station. You've got either an AKS 31 level switch or an AKS 4100 level sensor, or both, depending on what you want to do. Controlling through a level controller. After lunch, we'll touch on this stuff a little bit. But you can see that the valve station is there, and otherwise you'd have a whole bunch of stuff singularly. And it cleans it up really nice. You got a solenoid where the solenoid can close and stop it, or the solenoid can open and the ICM valve can modulate. You can't see this, but I just want you to be aware of the ICM nomenclature so that you understand it. So when you look on the side of an ICF, you can come up and look at this one. It's heavy, you can move it around. It'll have a silver label on it. It'll say ICF. That one will say 25, so that's the size. 20 would be 3/4 inch. 15 would be 1/2 inch. So 25, and then dash, the next number is the number of modules. So it'd either be a 4, with the large it could be a 3 or a 4, but with the small it's going to be either 4 or 6. In this case, that one's a 6. And then the last number is the one that's not as easily understood, and you got to know a little bit to understand it, and that's called the application. So you can't see this up here, but the most common that we see would be like liquid feed with defrost. So that would be a number 2. Or let's say liquid injection would be 5. Hot gas is a -9. So a hot gas valve station application would be a -9. That means it has these functions in it that are listed. So we standardize, and we can, I mean, eventually, you know, we can do custom, but we typically don't, because generally it comes down to specific application. And there's lots of application numbers, but here in the US we only use certain ones. In Europe they use, you know, different ones. But in our literature it'll basically tell you what it is, okay? 41 and 42 are return, like you'll see, I'll show you a slide with it. Okay, so this breaks it down. Application 1 is without defrost, so it's a liquid feed. So you see you've got a stop, a strainer, a solenoid, a manual opener for that. You got a hand expansion and you got a stop. Okay, so the hand expansion is your control. Okay, that's a pretty common one without defrost. Then when you have defrost, you're going to come down here, you're going to see you got a stop check there instead of a stop, okay, so that you prevent that backflow. The difference in the next one is just a stop valve and a hand expansion valve. Okay, so there's a lot of varieties. Here is the hot gas I was talking about. Okay, so it's generally going to have a solenoid, stops and a filter. And then application 5 and 6 were what we looked at on that liquid separator from the receiver feeding. That's going to have an ICM valve on it generally, in most cases. So you can sort of begin to see here, there's a trend, and you can see that you're usually going to have a stop and a filter, not always, but a stop and a filter and a stop, and then in between you're going to have your functionality, whatever it is you're trying to do, regulate or solenoid or, you know, control with ICM valve. And here's the big ones. So here's a good example of application 41 in a suction line. We saw that in that picture, and here's your condensate return. So there's your small port. You don't use that, because you would be upstream of the functionality. It's not going to, condensate's not going to get back. So here it's going to open right to that valve's going to be open. It goes right back down. This is closed during defrost. Does that make sense? Hopefully, yeah. Let's see here. So, and that's again, I'm getting redundant here, but I want to make sure. So here we're able to do the gas-powered valve, the ICS control in the large 50 and 65. Today we cannot do that in the small, the 15, 20, and 25. I think it's coming. It's being worked on in Denmark, and it's hopeful that we'll get there. It could be really good. And so here's application 42, which is a regulator, suction line regulator. So you can do all kinds of those configurations that we talked about. There's 20 of them. And ICM valve. We'll get back to that singularly, but again, control could be used in the suction line. And, you know, without a strainer or with a strainer in the ICF50. Ordering, okay, just know that just so that you know this, it doesn't come with coils or the actuator, okay? We haven't covered this yet, but this is the ICAD actuator for the ICM valve. It won't come with that. If you order this thing, you know, and you got you got that functionality on it, that'll have to come separate. The next is sight glasses. That's something new for us. They can be pre-mounted, and they're typically used for pulse electronic valves, modules, and ICM. So you want to see that you've got liquid there, and it's actually become very popular. And it goes in that side port, Okay, the cyclone screws right in that side port. So you would put it right before the valve. When you order the socket weld connections and side ports are going to be 3/8 inch NPT with socket weld. Okay, if it's butt weld, then it's going to be G connector. Installation. This is pretty self-explanatory. We've talked about this a little bit. Yeah, to the side and vertical is what you want. You don't want to flip upside down because that's why we have that stipulation that certain modules have to go on top, some have to go on the bottom, but it is possible in the small ones to turn it sideways. When you have an ICM valve, we don't actually encourage that. It probably would not be a good idea. So you can see that in the last block there. So that's for the small. For the large, horizontal. End of story. It's horizontal, that's what we recommend. So whether it has ICM or not, it doesn't matter. It's just they're physically so big and the way they operate, it just vertical's not a good idea. We're just showing here that yeah, there's people out there that do, you ever heard of MSI? They do tags. So these jobs typically have tags all over the valves. It's usually a safety requirement, PSM thing, yeah, all that. It's just, it's a good idea, and a lot of the people that make these are geared to putting the functionality on it with the nomenclature of our valve. It's pretty nice, like air handling unit 1, you know, HU, sometimes we see 1, sometimes AU, just depends on what they're doing. So for servicing the valve station, of course, we've got 4-bolt common access to all the modules. It's all stainless steel. If you order that module to replace it, it's going to come with the hardware. Modules can be turned 90 degrees without affecting any functionality, with the exception of the ICFE 25 with the armature. It can only go 2 ways. So, well, there's one exception to that. If you had a blank, which you typically would not before a solenoid, it probably was not going to happen, but that's the only thing you could turn it then maybe. So isolation with stop valves in first and last position normally. We recommend purge valves for vent and drain connections, okay, so the side ports, and then the filter module down below, which I just showed you. That's it for that. And here's some examples. Okay, so this is a gas-powered valve in the background. You can see it in a suction line because it's frosted over. And you can see the gas line going to the connection here that I told you about. Okay, that's the key. It's got to have gas pressure. So if I put it right there in that side port and that solenoid's closed, there's not going to be any pressure. If I put it in that side port, which is where he's put it with a purge valve, then that solenoid can be closed and I can still have gas pressure there. The other picture is similar, it's the same thing, so it's just showing how that's piped and how it gets pressure. Just an example of, this is an old, I say old because you can see flange, that's an old PMLX valve. But what you've got there is the suction in the middle with what would today be an ICLX, okay? And then you've got the hot gas there. Where's that? Hot gas is right here. And that's a valve station controlling that, and then your defrost drain regulator right there. So you got a 3-pipe system there. Here is showing, that's hot gas, I believe. Yeah, see the suction in the background, liquid in the background. Yeah, that's hot gas, so control. And then here, just an example of how, really I like the way this is done. So you've got all your evaporators that way, and then all your valve stations lined right up, feeding those for, you know, it's just really clean. So the guy needs to work on that stuff. he just walks right up on the roof and he's got access to it all the way up and down. It's really nice. Most times I see it in older jobs, it's clustered in big patches and you gotta go up and underneath and all over. So it's, I really like to see this. This is nice. Yeah, I know. So here's an interesting one that I came across out west. It's kind of interesting here. So this guy designed this thing, and he has 2 evaporators he's feeding, but he only wanted to use 1 ICF valve station. So he used 3 weld modules, and you can see it here. He's got one here, one in the one. Well, that's not a weld module. He's just welded to the valve station. Then he's got a weld module down here. So what he's doing is he's feeding here liquid control. So he's feeding to his evaporators, and then he's got, when it's in defrost, he's got his condensate. You don't see the check valves here, but he's got the condensate coming back. So in defrost, that solenoid is closed, and it can only go one way, so it's going to go through that drain regulator right there and back to the wet suction. He got away without having to use 2 valve stations. I wouldn't recommend that actually, but pretty cool, I guess. I don't know. It's just pretty clever. So a valve station that size is pretty costly. So let's say you did that 10 times in a system or 20 times, you could save a substantial amount of money as long as your flows and your capacities. And I'm assuming I'm thinking this was actually small evaporators. It wasn't like big, huge. So we got away with it, but I'd never seen that before. And you can see the example of what I run into all the time is he's operating on that a lot. So he's got the seal cap turned upside down on top of there. So he's something's going on with that. He's doing something. And here's another one. You can see the nice fog in the background and the mountains. I don't remember where this is. But here in this picture, it's similar to what we had before, suction regulator, which is the old one, defrost drain, liquid, hot gas. But the interesting thing here is liquid, you can see the yellow, and you remember what yellow is? Hand regulator. So a lot of times they use, on most, like there's not load changes or anything, you'll see the yellow cap valve station hand expansion valves. It's very common actually. If I run into, say, some where the load changes a lot, then they're going to use either electronic expansion valve or an ICM motorized valve or something like that for liquid control of the evaporator.